Hello, it's AK Mess. Today we try to do one of this geometry problem. So, given quadrilateral ABCD, given quadrilateral ABCD, and also given that the side of AB is parallel to side of CD, which I did it like this. Usually whenever we do some kind of two line segment or lines are parallel, we just do this kind of a symbols. All right, and AD is parallel to BC. Okay, so these two things are given. Need to prove that AB is congruent to CD and AD is congruent to BC. Nothing said that this quadrilateral is a parallelogram. We're not gonna concern about the parallelogram definition right now. We're just gonna prove that we have some kind of quadrilateral, and with a given that the two pair of sides are parallel, we need to prove that those two pair of sides for each pairs are congruent to each other. Okay, let's try. Proof. First things, we know that the two things are parallel. Two lines are parallel. Okay, if two lines are parallel, that's great. We can use transversal lines. So some other lines that intersect these two parallel lines. Okay, let's try. What are we gonna do? We're gonna connect A to C. We're gonna try to connect to A to C. Okay. Once we connect to A to C, this line is gonna be transversal to two things. First, it's gonna be transversal to these two parallel sides. And other things, I'm gonna do it a little bit later. Okay, so we have two parallel sides. Let's start with this side, AD and BC. With two parallel sides, and we have a transversal AC. Okay, so from the two parallel sides and transversal lines, we have lots of theorems like alternating and corresponding interior or exterior theorems. So we can use those theorems. All right. What do we know? We can say that two things sure. So if we working with these two sides, parallel sides, so we can work with this angle. So we can say angle CAD is congruent to angle ACB. All right. If CAD, ACB. All right. These two angles are the same. Okay. Let's make sure. Okay. So first things. Given stuff, we're not gonna write down already. Okay. Since we have given stuff, two sides are parallel, we can say that angle CAD is congruent to angle CAD ACB. Angle ACB. Okay, one angle is given. All right. What we can say about the other things? Can we work with this angle? It's kind of difficult. For now. Can we work with this angle? Yes, we can. Okay, we can do, because this angle is kind of opposite and nothing given except for the parallel sides and the we construct one transversal. Okay, so what we can say, we can work with another two parallel sides, this one. Okay, so we have two parallel sides, of course, and AC is going to be transversal to these two parallel sides. So if they're parallel to these two parallel sides, we have that, we can say that we can work with interior angles, that this angle is congruent to this angle. So these angles are CAB is congruent to ACD. Okay. Oh, for the first things we need to say by alternative interior angle theorem of, we could say that AD parallel to BC, and we could say and AC is transversal. Okay. This is the reason for why we chose alternative interior. Okay. Second. All right. Okay. Second, with the other pair of angles. Okay, angle, what we said, CAB. Okay, CAB is congruent to CAB is congruent ACD. Okay, same story by alternative interior the angle theorem, and in this case AB parallel to CD, and of course AC is transversal. All right, we have these two things. We have two angles. Okay, what we can say that so once we draw the transversal, which AC line, we created two triangles, ACD and triangle ACD and triangle CAB. Okay, we created two triangles. Okay, ACD and CAB. What we can say about those two triangles? Okay, three. From triangles ACD, okay, I start with this angle, I went to this angle, ended up, so I start with this angle CAB. All right, and triangle symbol, triangle CAB. What we can say? All right, we need to somehow to make these triangles to be congruent. So for the congruency, we have the postulate like SSS, which means side side side. What do we have? Side angle side, angle side angle, angle side. Okay, what we can use for angle? We have angle, but we need this side. Or angle, we need this side to be the same, but nothing said about the sides to be congruent. We only have that they are parallel. What are we doing? We're proving that this pair of sides are congruent to each other. Okay, what we can use? We cannot use this one. Of course, we have one angle. There is no angles here. So let's try to somehow figure out this one. Angle, side, angle. All right. Angle, side, angle. Okay, so from angle, side, angle, we need one side. But this side must be between this angle. Oh, okay, we have angle, and this side. Oh, that's great. Why? AC, line segment AC belongs to first triangle. Let it be triangle 1 and let it be triangle 2, Okay, and to the second. That's great. Okay, from this two triangle, what we can say? From this two triangle, we can say that AC is congruent to AC by what? By reflexive, by itself. By reflexive, we could say we already mentioned for this two triangle. Okay. So we have all the elements. We have two angles. We have the side between these angles. All right, that's it. So number 4, this two triangle ACD is congruent to angle CAB by angle side angle theorem. That's it. Okay, we proved that these two triangles are congruent. Perfect. Now once the triangles are congruent, of course their parts, their corresponding parts are congruent to each other. Now, so let's see. So if I count with this angle, I ended up here. So this angle corresponds to this, so which means this part is correspond to this part. Okay, nice, perfect. And same story if I count, if I reference to this angle, I'm corresponding to these sides and of course to these sides. Okay, perfect. AB is congruent to CD. Perfect. Okay, AB is congruent to CD. Oh, I forgot one thing over here. So because we're working with the line segments, that's why. All right. AB is congruent. AB is congruent to CD, and AD is congruent to BC, and AD is congruent to BC by corresponding parts of corresponding triangles are congruent. CPCTC. Okay, are congruent. Okay, that's it. All right. Proof is done. Thank you very much. See you in the next video.